Last year, a team of scientists in China did something that shocked the entire world. Over a 44-week trial, 10 elderly monkeys received a bi-weekly IV infusion of a special type of stem cell called SRC, and they found that the stem cell treatment successfully reversed aging in monkeys. And the monkeys literally got younger after taking the stem cells. In fact, after the study came out, Vladimir Putin and Xi Jinping were caught on camera discussing the possibility of humans living to 150 years. Because now, thanks to science, people are seriously starting to think it's possible. But that's a bit far-fetched to say now, because these stem cells have only been tested on monkeys so far. And that's why I decided to test this on myself. And for the next 32 weeks, I will inject the same type of stem cells into my body to see how it affects my biomarkers. And I'm going to document the entire journey from start to finish, so you can see exactly what happens. And this is episode 1 of the longevity experiment. Now, before we get into this video, it is important to note that this is not medical advice. This is only for entertainment and educational purposes. Everything you're about to see was done under direct medical supervision. So let's get started. This is day 1 of the experiment. I'm feeling a bit excited because no one has done this before. And I'm going to be one of the first humans to inject the same type of stem cells that reversed key signs of aging in monkeys. We spent the last few weeks building a panel of my baseline, doing MRI scans and sourcing the stem cells. We got the cells from the Wharton's jelly, which is the gel inside the umbilical cord. It's usually obtained from donated birth tissues. We got ours from our partner's GMP lab, and my wife, Silvana, who was also the medical doctor of the clinic, was against this experiment at first. And look, I get it. She was just worried about me. I mean, she's my wife. It's one thing to design a protocol for a patient. It's another thing entirely to what your own husband volunteered to be the first one in the chair, right? So the doctor in her and the wife in her were pulling in opposite direction. But the thing is, I knew she was just as excited about the science as I was. So she believed in it. So after going back and forth with her, she decided to do the experiment. And right before we started, I remember just looking at her and not saying much, because she had gone from telling me not to do this to being the one about to put also the needle in me. And I asked her one more time, are you sure about this? She nodded and she said she'd rather be the one doing it than have someone else do it with me. And that was it. So let's do it. So I'm going now to inject 120 million stem cells split between orthopedic injections in my shoulder and IV infusion. So everything actually can circulate through my body, and I'll be putting the same amount of stem cells every 6 weeks. And the infusion usually take 20-30 minutes. And while that's happening, let me explain the science behind these stem cells. Okay, so the first thing you need to understand is there are 2 types of stem cells you can actually put into a human body safely and legally. The first type is called autologous. That's just a fancy word from your own body. Doctors can pull these from your own bone marrow, your fat, or your blood, concentrate them, filter them, and then put them right back where you need them. And your own stem cells are incredible. Think of them as your body raw material, blank cells that can turn into whatever you're running short on. When you tear something, they are what rebuild the tissue. They are a huge part of how a wound closes, how a broken bone knits back together, how your skin repairs itself. This is also why the most established stem cell treatment we have, a bone marrow transplant, can save the life of someone with blood cancer like leukemia. And that same repair and regenerate ability is exactly why researchers are chasing them for everything else. Worn out joints, aging skin, and slowing down aging itself. And here's the problem though. You are born with the strongest, most potent stem cells you will ever have. And somewhere around your mid-20s, that supply starts to drop off, not just in number, but unfortunately also in quality. And part of that is just aging, but it gets accelerated by everything life throws at you. Chronic stress, bad sleep, drugs, antibiotics, vaccines, and the environmental load you carry around, like heavy metals and toxins that quietly build up over decades. So the older you get, the fewer good stem cells you have, and the ones left aren't firing the way they used to, which is the cruel part. By the time you actually need them most, when you're older, more beat up, aging faster, your own supply is already past its prime. That's exactly why people turn to the second type, which is the allogenic type. And that just means from a donor, from someone other than you. And the best ones comes from young, healthy birth tissue, like the Wharton's jelly inside an umbilical cord. That's where mine came from. And these are young cells at peak potency before life had a chance to wear them down. Now, there is one more thing that separates a world-class stem cell treatment from a mediocre one, and almost nobody talks about it. It comes down to one single number. When a lab gets young donor cells, they don't have nearly enough to treat anyone yet. So what they do, they grow them. They grow them in a lab and they let the cells divide and multiply in the lab, round after round. And each one of those rounds is called a passage. But here's the catch. Stem cells aren't immortal. Every time you multiply them, they drift a little further from that young, powerful cell you started with and push them too far, somewhere around passage 8 to 12, and the cells basically start aging themselves. So scientists call it senescence. So a cell at passage 12 might technically still be a stem cell, but it's tired, it's weaker, it doesn't home in on damage as well, and it can even start throwing off inflammatory signals, the exact opposite of what you want when the whole goal is to lower inflammation and reverse aging. So why would anyone push that number so high? One reason: money. Every extra passage multiplies how many doses you can sell off a single donor. It's cheaper, it scales, so the high volume clinics do it. We went the other way. We kept ours at passage 6 only, which are younger, stronger, and closer to the original cell, which is a lower risk. It costs more and gives us fewer doses, but I'm putting these into my own body and to the body of some of our patients. I'm not about to inject myself with the tired, cheap version. And here's another thing that most people, actually most doctors, don't realize. Not all stem cells are created equal. There's a whole menu. You've got embryonic stem cells, which are the most powerful of all. They can become literally any cell in the body, but they come with serious ethical baggage and a real risk of forming tumors. So they're not what's going into people in a clinic. And you've got iPSCs, which are adult cells that scientists reprogram in a lab to act young again. Promising, but they still carry a huge, big tumor concern. And then you've got the ones actually used in treatment today. Hematopoietic stem cells, the blood and immune ones from bone marrow transplants, and mesenchymal stem cells, or MSCs. These are the workhorses of the whole regenerative medicine world today. They come from bone marrow, fat, or cord tissue, and most clinics you hear about are using usually these ones. And there is the one I chose, which is Muse cells. And why Muse cells over the standard MSC everyone else use? A few reasons. MSCs are what's called multipotent. They can become a limited set of tissues, mostly bones, cartilage, and fat. Muse cells are pluripotent, meaning they can turn into almost any cell type in the body, similar to an embryonic stem cell, but without the tumor risk that makes embryonic cells too dangerous to use. The bigger issue with regular MSCs is that most of them don't survive the trip. When you inject them, a huge percentage die off quickly and never actually reach or embed into the damaged tissue. I'm talking about 97%. And that's where Muse cells are different, and the clue is right in the name. Multilineage, differentiating, stress-enduring cells. They are built to survive stress. And that's actually how they are found in the first place, completely by accident. Back around 2010, a Japanese scientist named Dr. Mary Dezawa at Tohoku University was working with ordinary MSC cells, and during the process a batch of cells got left sitting in a harsh digestive enzyme, the kind of stress that's supposed to kill all of these stem cells. The team noticed when they came back the next day that within the normal population of cells, a small subpopulation survived severe stress like prolonged enzyme treatment, low oxygen, and being starved of nutrients, right? And they killed most of the other cells. Almost everything died, like it was supposed to be. But this tiny group, they refused to die. And instead of throwing them out, she got curious and studied survivors. And it turned out these stubborn little cells were something nobody had described before. She first identified them in 2010 and named them Muse cells. The stress-enduring part of the name is literally how they were discovered, the one tough enough to survive what should have been a death sentence. And it's exactly what makes them useful inside a human body. They can handle the harsh journey through your bloodstream and the hostile environment of an injury site, actively going into the damaged tissue and then integrate into and become the cells type it needs. They don't just pass through signaling, they stay and rebuild it. They even carry receptors that guide them to the place of the injury so they can find the damage on their own and start repairing. And here's the safety part that matters most. Unlike embryonic stem cells, Muse cells don't form tumors when transplanted in the body, which is exactly what makes them safe, enough to actually use. So you get the versatility of a powerful stem cell, the durability to actually survive and reach the target, and a naturally occurring cell with a low tumor risk. To me, that's a combination why Muse cells were the obvious choice. But here's where it gets even crazier. And this is the version that went into those monkeys. The scientists in China took stem cells and genetically edited them at a single gene called FOXO3. And FOXO3 is what researchers sometimes call the longevity gene. People who are born with our more active version of it tend to live longer, healthier lives. Think of it like a master switch inside every one of your cells that control how well that cell can repair itself, it handles stress, and defend against damage. The problem is, as you age, that switch naturally starts dialing down, and your cells get worse at protecting and repairing themselves, and that's aging at the cellular level. So the researchers made two precise edits to that gene, essentially jamming the switch permanently in the on position. Then they turned those edited cells into a repair-focused type and called them SRCs. Senescent resistant cells. In plain terms, a stem cell that doesn't age the way a normal cell does. That's the version that went into the monkeys. It's not what went into me. Nobody outside that trial has access to these very specific time cell except me. And what I can access both legally and safely is a natural stem cell that offers similar benefits without the genetic engineering or unknown risk. So now let's get back to the experiment. It has been 3 hours since I took the first dose, and I don't feel a lot of changes. Honestly, I expected a rush, some fatigue, soreness where the needle went in, or anything that told me my body had registered a foreign cell entering it. Instead, I felt nothing. A bit pain on my shoulders. I checked the injection site in my shoulder, maybe, I don't know, 5 times today, but there was nothing to see. And my wife kept telling me that was actually the correct result, because if anything went visibly wrong on day 1, that will have been the bad outcome. And this is because Muse cells don't work like a stimulant. They are built to travel quietly through your system, find damaged tissue on their own, and start signaling to the cells around them before differentiating into whatever that tissue needs. None of that shows up as a feeling. If it shows up at all, it shows up in my blood work in the next month. And that's actually why we split the delivery the way we did. Exactly how the monkeys also got it. The orthopedic injections went directly into my shoulder and elbow, where most people have gotten wear and tear from daily movements. And in my case, I'm doing it only on one side to see through an MRI scan the difference between one side to the other. And then we did also an IV infusion so the rest can circulate and reach other parts of my body. Now, the orthopedic doses are meant to work fast locally, whereas the IV dose is supposed to show up on the blood work panels weeks down the line. So tonight, I did what I normally do. I had dinner with my wife and my daughter, and then I went to bed at my normal time. Now, I know some of you watching this are going to say, of course you feel fine, it's day 1, or maybe none of this does anything at all, and I'm about to spend months finding that out the hard way. Honestly, that's a fair thing to think. I think so too if I were watching this. But that's exactly why we're not relying how I feel. My next blood work panel comes back every 2 months, and that's the first real data point. Until then, I'm just a guy who got a stem cell injection. I keep coming back to the fact that nobody done this before. So there's nobody I can call and ask, is this normal? Maybe in 2 weeks I will feel amazing and I will have more energy. Or maybe something goes wrong and my body reacts to the 200 million foreign cells in a way nobody predicted, because the only data we have is from a monkey, not a human. What worries actually the most is that Silvana is also doing this, and I will not be able to forgive myself if anything bad happens to her. But the only way to find out is to do it yourself. So in 8 weeks, I will show you what happens to my body after the first dosage.